The most common way to teach how to multiply a binomial times a binomial is to use the acronym FOIL, F-O-I-L, to help people remember what order to multiply in. F stands for first times first, O is outer times outer, I is inner times inner, L is last times last. And this is a great way to remember what's going on, but it's also good to think of this in terms of distribution. So as I go through, I'll point out where the F, O, I, and L are, but I'm going to primarily look at it as a distribution problem. In this case, I'm distributing something to x minus 3. And if I look over here, I'm distributing a 2x and a positive 1. So really, I'm just distributing two things to the x minus 3, and then combining like terms. So let's see what that looks like. When I take the 2x, I need to distribute them first to the x. So I get 2x times x is 2x squared. And that is the F in FOIL, because it's the first times the first. Then I take the 2x, and to complete my distribution, I need to take him to the negative 3. So 2x times negative 3 is negative 6x. That's the O in my FOIL, outer times outer. Now I've completed all the distribution that goes with the 2x. I need to start distributing the 1. So I take 1 times x and get positive x. I like to line up all of my like terms and even put a 1 with that x, because then it's going to be easier to get my final answer. That's the I in FOIL, because it's inner times inner. And finally, I have to complete my distribution by taking the 1 times the negative 3. That gives me negative 3, and I'm going to put him over here in his own column because there's no like terms, no constants yet. And that is the L in my FOIL, because it's last times last. So I come down here to what I just FOILed out, what I just distributed, and I'm going to add everything vertically. So when I add straight down, I get 2x squared, combine like terms, minus 5x, and minus 3. So when I multiply those two binomials, I end up with a quadratic trinomial of 2x squared minus 5x minus 3. If I look at a second example and continue this idea of distribution, I can think of it as FOIL or distribution. It's going to actually get me the same place. So here I'm going to distribute the 3x to both of the pieces. So 3x times the first 3x on the right gives me 9x squared. 3x times 4 is positive 12x. I'm done distributing the 3x. Now let's distribute the negative 4. So I get minus 12x, and then negative 4 times positive 4 is minus 16. So if I go ahead and combine these things vertically, I get 9x squared. My positive 12x and negative 12x cancel out, minus 16. So this is a case where I actually get a quadratic binomial. And if you look up here at my original binomials, there's something really odd about them. They're exactly the same except for the middle sign. We call a pair of binomials like that conjugates. So that is what's called a pair of conjugates. And anytime I FOIL out a pair of conjugates, I get a binomial. That's the only way I can FOIL out any sort of binomials and get a binomial as my answer. That's going to be a very important concept once we get to factoring. One final example. Well, what does it mean in this problem here to square something? We know that to square something means to multiply it by itself. So I take 3x plus 2 and just write them again as a multiplication problem, 3x plus 2. So what didn't look like a FOIL problem right off the bat actually turns into one when I look at it multiplied in this way. So I FOIL it out, or I distribute the 3x to both pieces, which gives me 9x squared plus 6x. Distribute the 2 to both pieces, I get another plus 6x and a plus 4. So if I add everything straight down, my answer is 9x squared. Now be careful, some people want to cancel out the 6's, but I'm adding, and they're both positive. So I get plus 12x plus 4. So again, when I FOIL out these binomials, I get a quadratic trinomial as my answer. So again, when I multiply binomial times binomial, you can think of it as FOIL, first, outer, inner, last, or just distribution that has to happen twice.